All right, it's my real pleasure to have Ashton Verdery with us today. Ashton is a professor of sociology and demography officially, right, at Penn State. I've known Ashton for years. It's just remarkable to work with him. If you get the opportunity, don't ever turn it down because the guy is just a powerhouse. It's just absolutely remarkable. His work covers substantively work on grieving. You've probably seen all the news reports on how many people are grieving because of the death of COVID. That's Ashton. All of the work that's been done on the opioid crisis in Appalachia is part of Ashton's work, as well as a whole bunch of work on diffusion and things like Ebola and disease outbreak size and so forth. So it's a really hugely diverse work. And one of the areas that he's made his mark in, and we keep bringing him back for every year, is to think about responder-driven sampling and the ways in which we can do these adaptive sampling designs in smart ways. And he's one of the world's leading experts on this field, and we're really excited to have you back, Ashton. Thank you.
Thank you for having me, and as usual, a too kind introduction. I was told this is the advanced class, and that most people had already kind of reviewed a lot of the materials. So I kept maybe about 25% just of overview-related stuff and hope to get into some of the more advanced topics related to link tracing designs that are possible. So kind of as a general kind of orientation, I'm going to talk about kind of intuition regarding network sampling, and then go through why we would want to do it, and this is kind of the repetition stuff, and then think through some of the specifics of respondent-driven sampling, which is the most popular method of it, and then think through some of the specifics of sort of alternate approaches that I think hold great promise, are still somewhat in development, but I think have great potential to kind of add a complementary toolkit to the link tracing designs that allow for inference. Intuition-wise, the idea here is that we have some sort of social network, and we want to know about the people in it, and we could sample a person who refers us to another person, who refers us to another person, and through this kind of referral-based process, learn something about the population beyond the people that we sampled, learn something about the network beyond the immediate cases of people that we sampled. So why would you want to do this? I think that I feel like an evangelist about this, but really this is the future of social science research. To the extent that we are collecting data on people interpersonally, I think that we need to have complete recognition of the ability of link tracing designs to complement our kind of scientific studies. There's a number of new populations of interest that are really difficult to sample with traditional protocols. There are also kind of new theories and tools in all this social networks and health research that is kind of advocated here that require us to have some inference or some knowledge about the connections between people. And then there's this kind of 5-alarm fire that is kind of being ignored, I think, by most social scientists, but we're all going to be out of jobs in 20 years if the trends continue that I will come back to in a couple slides, but this trend of kind of declining survey participation poses huge threats. And so new ways to recruit samples that maybe overcome that, I think are absolutely critical for us to pay attention to. So here's the 5-alarm fire issue. We know that survey participation rates are declining tremendously. These are kind of numerous major surveys. This is into the kind of mid-2010s, and you can see this kind of general secular shift in all surveys of this declining participation rate. And even surveys that look great on paper when you look at their response rates, like the panel study of income dynamics, AdHealth, PSID, HRS, GSS, these studies that we think of as like, oh, they're maintaining high response rates. They're doing that at the expense of a tremendous amount of other science. Here's the average price of kind of recruiting a person into the PSID over time, and you can see this enormous shift that's not entirely due to increases in the length of the interview, but enormous shift in kind of the incentives that we have to offer. And doing that takes away research funds from other potential kind of uses, and this is a really big crisis. Of course, there's good news on this, and this is my kind of, I always laugh about this slide. So this is, Pew put out this thing like, great news, survey participation rates have stopped declining in recent years at 9%. And I think if, even if they go down a little bit more, they will eventually stop at 0. So we will somehow have some potential to go further. So coming back to that kind of broader issue of what RDS and what network-based samplers are interested in, they really came out of this desire to sample what are considered hidden populations. Hidden populations are defined as those that lack a sampling frame. And And it can be very difficult to sample them because they're very rare in the population of interest. They might not want you to know that they're members of that population, or they don't trust survey researchers, and they don't want to kind of participate in things. They could be in highly stigmatized settings where they might be arrested for drug activity or something like that. And so they have a great deal of distrust. And so there's no centralized list that you can sample them from. But most of inferential statistics comes from this kind of like forest-based model that we're kind of used to thinking about for sampling, where you have a forest and you can, you know exactly what where the forest is, and you can pick points in the forest and sample the trees and understand it. But for people, this doesn't work because people are not forests. And there's other designs for that. But still, ultimately, people, they don't conform to that kind of basic model, which poses real challenges for a lot of survey sampling. Now, we've done great jobs with household-based surveys and things like that, but they face that response rate crisis. And so we need to think of ways to kind of get people into surveys that we can learn about populations beyond just the sampled units while still maintaining high response rates. And all populations are kind of becoming hidden at this point. So the traditional approaches to sampling hidden populations that lack sampling frames is just do whatever. Talk to some people, get some people to enroll in your study. It might be that you go out and put up flyers and you recruit a convenience sample. It might be that you have a clinic-based sample, or like for homeless populations, a shelter-based sample or something like that. All of these things, though, suffer from challenges of who comes into the sample might not look like the population of people that you're interested in making inferences about. And so are we learning about people other than those who are in the sample themselves? In general, there are lots of kind of challenges to these types of things, and they yield kind of poor statistical inferences. So we don't know as much about the proportion of the population that has HIV in San Francisco, for instance. They also can pose challenges for researchers with like danger. They can be very costly and time-intensive to sample people. So these kind of convenience sample-based approaches might yield kind of poor quality results. And to solve that issue in the late 90s, people proposed this idea of respondent-driven sampling, which is kind of a social networks and health-based way of sampling people through their social ties and getting respondents themselves to drive the sample recruitment process. You recruit a certain number of respondents, you give them coupons, and you ask them to recruit their friends that are in the social network. And this allows them to identify who's in the network, and it kind of reduces some of the researcher-based burden. So RDS is a hugely popular method. It's made enormous inroads in public health. In kind of recent decades, there have been over 120 funded NIH studies about it, 1,700 publications using respondent-driven sampling data. If it were a scientist, it would have an H-index of 80 per Web of Science. So it's a very accomplished kind of method. Was that a question? Oh, okay. And if you compare it to kind of other network-based approaches, it actually is doing a huge kind of outsized amount of kind of network data collection comes from the RDS literature. Egocentric research, for instance, from NIH has been funded at substantially smaller levels than respondent-driven sampling research. RDS is used for a wide variety of hidden populations, including most commonly people who inject drugs, but also other populations at high risk of HIV, as well as kind of more creative or sociological kind of applications that I wouldn't have thought of in my research, but have been kind of interesting cultural sociology applications and things like that, like jazz musicians or vegans, or people who use wheelchairs. There's all sorts of kind of subpopulations that have been recruited with RDS. If you look at what NIH institutes are funding it, you'll see that it is pretty dominant in the HIV realm, from NIDA, which deals a lot with drug-using populations, and NCHSTP, which is hepatitis, HIV, and something else. And so it's mostly used for these kind of populations at high risk of infectious diseases. The most common questions that researchers ask with RDS data is, can we learn anything about this population at all? From a quantitative perspective, as well as what are the characteristics of it, what percent have HIV, what percent use condoms, that sort of thing. As well as there's a subset of kind of RDS research that tries to estimate population size from the sample that's recruited. As I mentioned, the big funders of it are kind of these people who are concerned about infectious diseases, and you see the kind of fields that are publishing in RDS are very much dominated by that as well. So to give a very quick overview of what RDS looks like, it's got two basic parts. The first part is this chain referral component, where you recruit a number of kind of seed participants. Typically, they're just a convenient sample, although there's some recommendations to try and diversify that seed recruitment. You give each person a coupon to participate in the study, and you ask them you give them a couple coupons. You ask them to go out and hand out coupons to other members of the population of interest. So if you're interested in people who inject drugs, you might say, give this to other people you know who inject drugs, under the theory that people in the population know one another and would be able to distribute these coupons. And you have a clinic site where people come in and they redeem their coupons, and you need a coupon to enter into the study. So you don't just take anyone who comes into the study, you only take those who have a coupon. And each coupon has a unique tracking code that allows you to determine that I gave it to person X, I gave the coupon that person Y is redeeming to person X. And so you can track the interpersonal links semi-anonymously in the network through this kind of respondent-driven recruitment process. In general, you continue this process until you run out of money or the sample size is reached. And you don't let people participate more than once, because you don't want a situation where I recruit Jimmy and then Jimmy recruits me and then I recruit Jimmy and Jimmy and I get rich, but the study only has 2 people in it. The fundamental property of RDS is the researcher really lacks control of the sampling process, which is pretty different as a reorientation of your mindset from the kind of traditional sampling approach where you draw the sample frame, you say, I'm gonna sample these people. It's very different. You go out and the respondents themselves are driving recruitment. So it's a pretty big shift. The second part of RDS is this post-recruitment weighting of cases to kind of increase representation. Because of the peer referral nature of RDS, you end up recruiting people who are more popular in the network, are more likely to be sampled by their peers, for instance. And so RDS tries to correct for the theoretical properties of sampling to come up with a way to give the less popular people more weight, the more popular people less weight, and that sort of thing. And from that, you can make inferences about the population itself.
So I just have a quick question. Do you know of anyone that uses this method to get people who match the criteria as well as those who don't? Because sometimes, like for instance, you might have HIV and someone you know has it as well, but you don't know each other have that. So when you're doing this maturation, double sampling RDS method, and not getting those members that aren't known to be a part of that group or criteria, then you're only getting one side or one picture of the network.
Yes. So in general, you wouldn't try to recruit people who only have HIV, but you'd recruit high-risk population. That is like people who inject drugs or commercial sex workers or something like that. And under the theory that people will be able to identify other members of that population. But that's an area of kind of challenge for the literature, and one of the diagnostics that's sort of proposed is and why some of the population size-based estimates are particularly useful to try and understand how visible is this population? Can people identify their peers that are members of it? In the network scale-up literature, one of the big questions is would your friends identify you as a member of the population? And those sorts of diagnostics are increasingly incorporated into RDS in a way to try and quantify that kind of uncertainty. Does that make sense? So the idea, you have these coupons. Usually the coupons give kind of information. They say a specific valid date, the location of the sampling center. They'll give you information about what the coupon number is and things like that, how to participate in the study, the incentives. And you give those to respondents and they give them out in the community. One of the key properties of RDS is that you only give a small number of coupons so that each person is recruiting a couple people who then go on to recruit other people. You don't want a situation where one person recruits 40 of your sampling members, for instance. So 2 to 3 per respondents. And you track the recruitment process, which gives you some information that you can use to make that post-recruitment weighting done. So the resultant data is often graphed to look like this. This is from a Duke graduate student, former Duke graduate student Jake Fisher and Giovanna Murley, where they graphed a respondent-driven sampling in Luzhou, China, where in this setting, people tend to work in kind of different tiers of sex work, kind of more high-end places and more street-based sex work is a simple distinction. And so they graphed the tier of sex work with colors that people of each node and the kind of size of the venue that they work in with the size. And you can see a lot of clustering on both of those components in the kind of resultant data, where the top people are the seeds. They each recruited 1 or 2 people, who then all recruited 1 or 2 people, et cetera, going down. And eventually, some of these people, towards the end, they're only recruiting a few people because the population was kind of exhausted, and most of the people had participated. But you end up with this sort of resultant data. There are a number of kind of resources for analyzing RDS data. Because there's no secondary RDS data set that I know of, and I can't give the ones that I have access to everyone, I thought it didn't make sense to come up with a program coding kind of component. But I think you could use the RDS package in R, which is a really great resource for this, and very well explained, has all the estimators kind of implemented. There are also a number of data collection resources that I've listed here, and this I think is on the website. So they'll have manuals for suggested protocols, suggested consent forms, IRB forms, incentive amounts, and things like that I think you'll find pretty useful. So returning back to the kind of concepts of RDS and some of the practical kind of implementation challenges that exist. There are a number of baseline assumptions about the kind of social network that you're sampling from. The first being that the population members are linked in a network that exists. If you're trying to look at, for instance, sex work, like Johns or the people who visit sex workers, they probably are not linked to one another, and so it probably would not be a good method to recruit Johns into a survey. But sex workers themselves perhaps know other sex workers, and therefore it might work for that side of that kind of problem. And also that people are willing to refer others. If it's the type of thing that, it's a high risk, high stigmatized situation, people might not be willing to refer others, and that's kind of why you would need to do formative research to gather whether people are willing to do that. And then there's a number of kind of key concepts that play into the estimator quality and the ability to make inferences from your sample to the population. The most prominent one is degree-based measures of people's essentially popularity. There are also assumptions about people making random recruitment within their friend circle. And there are a number of kind of components related to the primary and secondary interviews that I'm going to get into because I think that's an underutilized resource in RDS. And then last, I'll kind of talk about some of the sampling variability from sample to sample issues, which still pose huge threats for RDS, and which the secondary method that I'm going to talk about is well suited to tackle. There are a number of different estimators out there, and they make different assumptions about, say, ties being reciprocal or not. But those are, in general, most of the things perform relatively similarly, and these assumptions are not as big as some of these ones here. So I'll just go through those top-level ones. The degree-based assumption is that people who are more popular are more likely to be recruited into the sample. We took a sample of a kind of assumed RDS network, assumed commercial sex worker network, and we simulated thousands of RDS samples following the traditional protocols on that network. And what you see here is really under any sort of different way of looking at it, you end up with the more popular people are more likely to be sampled multiple times. This is just the nature of kind of network-based processes and how sampling works. And so you end up with more popular people more likely to be sampled, so you need to adjust for that degree through a variety of the estimators of coming up with weights that kind of give an inverse weight for the high degree nodes to be counted less and the low degree nodes to be counted more. Typically, degree is measured through kind of a standard degree-based measure of how many people do you know and they know you, and you've interacted in the last 6 months or something like that, and that are members of this population. So that's the basic degree idea. One of the critical assumptions of RDS, and one of the ones that is the most challenging to test, and in the classic formulation of RDS was an untestable assumption, is this idea that people are going to recruit their members at random. So the traditional math of RDS comes from the random walks kind of literature, and this idea that if you take a node in a network and they randomly refer you, and that node randomly puts you in contact with another node in the network, and if you repeat that process, you'll end up with a degree-biased sample, but that once you do the weights, you end up with a representative sample that you can make inferences to the population. But that is only true to the extent that respondents actually refer you at random amongst their peers, which is often not the case. The typical RDS, like the World Health Organization's RDS manual, suggests that when you give coupons to people, you tell them a script like this, and give coupons to people you know. If possible, try to give the coupons to different types of people you know, which is how they're kind of operationalizing, distribute them at random. But of course, different types of people is not the same thing as exactly at random, right? So it's a bit of a challenge between like the way that the statistical inference from it is operationalized and the practical implementation in the field is done that I think is a big challenge for RDS and only now is beginning to be diagnosed and to be corrected for. So this idea of random recruitment would be if you had node A and they were connected to B, C, and D, that each of those nodes would have equal probabilities of being referred by node A, like 3/9 in each case, even despite the attributes being different, et cetera. But of course, we can imagine that people are more likely to refer nodes that maybe they have better connections to, which might be like homophilous kind of processes, and less likely to refer nodes that are different from themselves. And in which case, we end up with this kind of preferential recruitment process that could potentially bias the results above and beyond just who's connected to whom, but really this kind of referral-based patterning of referrals that might yield preferential recruitment and therefore kind of invalidate that assumption of random recruitment. So in general, the preferential recruitment idea is not that, or the random recruitment problems are not that people are connected to people at differential rates, but really that like they refer among their kind of binarized network connections at differential rates. And there are a number of reasons that they might engage in that. You know, one that I mentioned is they might have better relationships with certain types of people. Another one might be that they think that their friends who are engaged in riskier behaviors need to participate in the study to get tested so that they'll know and make better choices. Or they know that their friend is down and out and needs money. And so they're more likely to refer someone who they think needs the money to participate in the survey. So these things can result in a number of problems. And with Jim and Giovanna, we have a kind of unpublished manuscript where we tried to diagnose different ways of thinking about this and those kind of recruitment level behaviors that could yield biases. So in general, it's been under-theorized, the kind of recruitment behavior process. And people have really only looked at like the types of ties they have and some extent whether they're recruiting randomly amongst their friends, but they haven't thought about like the mechanisms that drive that. And so we tried to kind of operationalize this in terms of having differential offering behaviors, differential accepting behaviors, and differential reporting to the survey behaviors as being 3 stages of the recruitment process. So the first stage would be I have a coupon and I choose to give it to a certain type of friend. The second stage would be certain types of friends are more or less likely to refuse a coupon. And the third stage would be even if they take the coupon, maybe they throw it in the trash, or maybe they go to the study. And so we tried to think of those 3 components, as well as mechanisms that might be based on recruiter attributes, recruitee attributes, or attributes of both parties. So to kind of illustrate this, offering behaviors would be like you choose to give coupons to certain types of people, but not others. Accepting behaviors, you're thinking about like only taking coupons from certain types of people. And then you might have this kind of trashing the coupon kind of problem. And you could do it by recruiter attribute, recruitee attribute, or both attributes. One thing that this under-theorized process comes into play for is that we have a tool to diagnose that kind of activity, but it hasn't been utilized in RDS studies. So I came up with this graphic of the traditional kind of way that RDS is represented versus what actually occurs in the field as a way to help think about that. So it's typically represented this way, where you have a seed, and they recruit 2 people, who then recruits, one of them recruits 1, the other one recruits 2. But in practice, what actually unfolds is that it's a dynamic process that happens over time in the network. And so person A recruits person B at time 2, and then only a couple days or whatever later recruits person C. And so these things are kind of unfolding in a sort of staggered fashion that you could actually leverage to understand the network itself and the kind of biases in recruitment that might be occurring. And so one thing that is kind of an underutilized resource in RDS is because you give people coupons to recruit others and they get a secondary incentive for having done so, usually they have to come back to the survey site to collect that secondary incentive, which gives you the opportunity to have a short secondary interview. And so that's graphed here, where person A reports for their primary interview, person B for their primary interview, and then because person A recruited person B, they come back for a secondary interview, et cetera. And so you can see this kind of return kind of process, which you could use to collect additional information on who you gave coupons to, whether they accepted those coupons, and then subsequently to track, did the people who came into the survey as like secondary recruits, did they look like the people that were coupons were distributed to, or did something else intervene in the process? A lot of coupons in the trash, or maybe second level passing on of coupons in the network, which would help with some diagnostic of the preferential recruitment problems. So I think that in designing RDS surveys, you should take advantage of those kind of secondary recruitment opportunities to come up with ways to track potential biases that are introduced into the survey and allow you to kind of diagnose those kind of issues and potentially correct for them. These offering, accepting, and recruiting behaviors, what we found in our study where we tried to break it out and simulate these is that the worst case is when people are recruiting on the attributes of the people that they're giving the coupons to, and in particular, when they're sort of like they give them coupons and the people throw them in the trash on the basis of their attributes. So it's basically the worst case when you're recruiting people because they need a test or because you think that they need the money or something like that. These have the highest potential for biases. And it's actually a little less consequential if maybe like, more engaged people in the network or something are more likely to pass out coupons. That's not as big of a problem as recruiting on the attributes of the person who receives the coupon. So pivoting outside of the kind of individual mechanisms of recruitment, I think it's helpful to think of the broader structural properties associated with RDS. If you run an RDS, you end up sampling the center of the network. This is true because of degree-based properties. We know that in general, degree centrality correlates with other measures of centrality. And in RDS, it's the same kind of thing. If you start an RDS from, say, like up here, it tends to gravitate towards sampling the nodes in the center, the black nodes in this, on a simulated RDS. Which has led people to kind of theorize that a huge problem for RDS is what's called bottlenecks, or when there are kind of breaks in the network and kind of different clusters in the network that would be difficult for the sample to cross. Because if you start down here, this is just a school-based network, but if you start down in the blue sector, you're most likely to end up in the center of the blue sector recruiting lots of people, and very unlikely to ever cross over into the black sector, therefore giving you a really kind of biased view of that network because of that bottleneck. The classic formulation of it in kind of early statistical work is they graphed it like this, a really like almost two bottle caps barely connected to one another. And the classic recommendation for RDS in this circumstance is to split the sample and run two separate samples and then combine with like meta-analysis technique or something like that. But this is all based on the idea that you can identify a priori that there are these bottlenecks in the network, which I think is challenging in most circumstances. Maybe if you know that a city that spans, like Ottawa and Hull in Canada span the Quebec and Ontario sides. And so maybe you can imagine that there are gaps between those, or the boroughs in New York or something like that. But those are kind of some circumstances where you would be able to split the sample effectively, but most of the time I think it's going to be difficult to a priori identify breaks in the social network without having seen the network at all to be able to kind of do that. The problem with bottlenecks is not that they increase the bias overall. In general, most studies suggest that bottlenecks do yield bias, but really, like if you repeat the sample from a random starting point many, many times, you end up relatively unbiased from RDS. But the problem is those bottlenecks greatly exacerbate the variability in the kind of sampling results that you get. So if you take, this would be like a network, and if you were to simulate thousands of RDSs on the network, you can say that this is the true value. This would be a biased case where the average across many, many samples is far away from the true value. This would be a less biased but more variable kind of circumstance, or have a greater design effect than traditional survey sampling would have. And so you end up with results that are really imprecise in any given sample. So each of these would be like one individual sample's mean might be kind of relatively clustered or very spread out. So to kind of illustrate that idea, going back to the network I showed, I simulated thousands of RDS samples on a specific network to try and estimate the proportion, in this case, of red nodes in the network. And doing so, you end up with, in the kind of RDS-based approach, you end up with each of these being one sample. And so if you plot a histogram of the sample means from thousands of samples, you end up with great variability in the kind of results. and substantially greater variability than you would with a simple random sample, which the ratio of those two statistics is often called the design effect, or how much larger a sample from RDS would need to be to give you the same statistical precision as a simple random sample. And you could increase the n, but you still end up with the same basic problem where the RDS is substantially, the results, one survey, one time you run it in the network, it says 20% of the network has HIV or whatever the attribute is, and another time it says 80%, and it's highly variable. Whereas if you ran thousands of simple random samples, the interquartile range might be like 55 to 65%. And this kind of contrast of precision of the estimates from sample to sample is a big challenge. So early kind of simulation-based work suggested that RDS had design effects that were substantially larger than was kind of being thought at the time. When it was first proposed, they said it was twice as variable as a random sample, a simple random sample. I think that they just kind of pulled that number out of nowhere, but they said twice as variable, so you should, if you want to have the precision of having 250 cases, you should collect 500. And then a couple months later, or a couple years later, somebody said it's 4 times as variable. And so if you want to have the precision of a 250-person sample, you should collect 1,000 cases. And then subsequent work with simulations and things like that was suggesting it's 8 to 10 times as variable. So really very, very problematic for kind of having good inferences about the characteristics of that population. Subsequent kind of empirical-based work has sort of called that into question a little bit. And unfortunately, I think that there's a disjuncture in the literature where people fundamentally think that if you create networks and you simulate RDS on those networks, that is going to be like the answer, when this is really an empirical question and it's kind of an unanswerable one because we can't run many samples on the same network. It's just fundamentally something that you can't do. You can't run 10 samples of injection drug users in Baltimore in 2010. It's just not a feasible kind of thing to do because they'll won't want to participate in your surveys anymore. And so fundamentally, we have to turn to kind of other ways to think about it. And so one thing that I've been trying to do is use some of the results from the National HIV Behavioral Surveillance System, where they run RDS samples in given cities multiple years. So this is from a paper by Cyprian Wainert and others, where they reported all these kind of attributes in the HIV behavioral surveillance system in these cities. So I took the inter-year kind of variability in 20 cities that were repeated and calculated like a test-retest statistic for those things. And what you see is that it's about a 0.73 correlation at the city level, which I think is actually pretty good. If you were to repeat a survey a couple years apart and found a 0.73 test-retest, that's a pretty good result. And it's about a 30% variability of the attribute. So like the percent deviation is about 30%. So I think that this does suggest that the estimates of sampling variances, design effects of 10 are probably too high, but certainly the 2s are too low. So early RDS work was focused on kind of understanding how much bias there might be, but there's another problem with the sampling variance being very large, as I described, and a related concern to that is your ability to diagnose that the sampling variance is very large. So it's one thing to say if you run 1,000 samples in this population, you'd have high variability. It's another question whether you can actually tell whether that's the case. And unfortunately, up until quite recently, the RDS kind of variance estimators were really bad at reflecting the variability underlying the sample. And I think that this is a kind of key problem because one thing that's nice about statistics is that with the law of large numbers and things like that, you can grab a sample and you can say with reasonable confidence where the confidence interval lies or something like that. But the RDS confidence intervals were far too low for what's actually occurring in reality. So an early paper about 12 years ago now on this looked at kind of simulated RDS samples in the ad health networks and other kind of places and found that the design effects are substantially larger and that the ability to recognize that high design effect was inadequate. There were a number of proposed estimators for RDS. These are kind of the main estimators for estimating the sample mean, and these are estimators for estimating the sampling variance. Most of these really struggle with ability to diagnose that the sample is highly variable, except for this tree bootstrap method by Baraf and al. So initially, If you took these two networks, this is a paper with Peter, if you take these two networks and you simulate RDS on them many, many times, like very stylized kind of toy networks, and you calculate the traditional variance estimators, you end up with the exact same estimates for the two networks of the variance, but the actual variance is substantially different between the two networks, which really, I think, showcased this kind of fundamental flaw in the existing estimators, which subsequent work has solved. So this kind of replicates the findings that we had from our paper, and then these are the newer tree bootstrap-based estimators by Adrian Rafferty, Carl Rowe, and other people. And what it finds is that these ones are, those variance estimators, this is the coverage rate on the bottom, so that is the percent of, or the proportion of times that the confidence interval overlaps the true value. And if you're making a 95% confidence interval, the coverage rate should be 95% or 0.95. And you can see these are, grossly inadequate. They're only overlapping the true value at 50% of the time, which suggests that you're saying that the sample's confidence interval is like this, when really it's like this, right? That's the problem. But the tree bootstrap method is able to kind of capture that value at relatively high rates, which yields ability to recognize, at least this case, that you have high variability in your results and make accurate confidence intervals. Of course, the problem with that is that because RDS has very high confidence intervals, like naturally, you might end up in a situation where you're saying, yes, the proportion with HIV in this population is somewhere between 10 and 90%, which operationally might not actually be that useful. And so the ability to recognize that circumstance, it's better to have the width of the confidence interval correct, but it still doesn't solve the fundamental problem that the sample is between 10 and 90% kind of confidence. There are a number of RDS diagnostics proposed to help you kind of diagnose some of these issues. I alluded to some about collecting to understand offering and recruiting and accepting behaviors, offering, reporting, and accepting behaviors. But there are other ones to try and estimate whether you self-identify as members of the population, if others would identify you, to get accurate degree-based estimates, et cetera. I have some notes on web RDS that I can come back to, but that was a question that I got a number of times, so I left it in. If you end up with problems in a traditional RDS, if you start running a traditional RDS, inevitably you're gonna sort of feel like recruitment's going slowly or it's not working or something like that. And I think it's useful to think about how you could course correct to improve the sample and get the resultant sample that you want. The typical recommendations for this, as with most surveys, pay the respondents more money if you can, recruit more kind of initial seeds to refer others into the survey, reduce the kind of burdens with survey participation, shorten the interviews, reduce the secondary interviews, so maybe just let them come in and collect that cash, even though that comes at a cost of reduced diagnostics, or expand the number of allowable recruits per person. Sometimes if you're only letting people recruit one individual, you're kind of setting yourself up for failure, and you might want to say, give each individual 3 coupons, because then they could, the more effective people could recruit more effective people, et cetera. If all else fails with RDS, you can still learn a little bit from it as a convenient sample or rely on some of the other features of the data. One of the things that I've recommended is to kind of embed qualitative interviews, ego network rosters, and things like that in RDS. So even if the RDS sample component doesn't allow you to make these generalizable inferences, you still get this kind of network-based data, which many of us are familiar with, like convenient samples of ego networks, and we can learn a lot from them. I also think it's worthwhile to look at RDS as doing things other than just telling us about population prevalence of a particular attribute. I think it's also useful to think of it as an ability to tell us about the network structure overall, or kind of multivariate relationships, et cetera. So I'm gonna move past this. So the big problem with RDS is this design effects remain high, that between 10% and 90% kind of estimate challenge. And the challenge there is that we would need to sample thousands of cases with RDS to be able to have some precision on the attribute that we're interested in, which I think is kind of a big challenge because these are generally small populations. As a kind of potential solution to that, Ted Mao and I proposed in 2012 this idea of network sampling with memory, which uses a lot of the logic of RDS, but returns the control of some aspects of it to the researcher by having them collect minimally identifying information and then asking respondents to recruit targeted individuals that we use from the revealed social network as the sample unfolds to be able to tell us about the sampling process and to be able to give us more effective recruitment protocols. So the problem with RDS is that the network is it exists, it's a tool that kind of helps you, but it is not an item of interest. The network sampling of memory with memory approach kind of turns that on its head and thinks, how can we use the revealed network to better direct the sample to get lower design effects? So the basic idea is to collect information on each respondent, ask them to give information about some members of the network and use that to kind of piece together the network as the sample unfolds. And while we're piecing together the network, we can say, this is the most effective person to recruit to reveal the most possible unique information. So the idea here, thinking back to that bottleneck situation, is if we have sampled the black nodes in cluster X, we want to be able to recognize that it makes much more sense to sample person 1 than it does to sample person 8 or whatever, because we want to cross that bridge, cross that bottleneck, and learn about the kind of other network, pushing through the boundaries, lowering the design effects, increasing estimate reliability, and improving all sorts of other estimates that we can make. So the idea here is we collect data from respondents about their networks, standard network protocol, ego network kind of survey design, but we also collect a small set of minimally identifying information about people so that if I nominate Jimmy and Peter nominates Jimmy, we can, as the researchers, determine that both of us were nominating the same person and therefore learn that, oh, well, two people who've already participated know Jimmy, it would make more sense to recruit someone who only one of them knows. And so we tested a bunch of different ways to do this in both simulations and empirically, kind of came up with a result that if you collect a small amount of network, kind of minimal sized network roster, and then a small amount of identifying information, like on 3 to 5 alters, that you can actually yield pretty strong estimates. So the idea of network sampling with memory is we sort of have 2 modes within it. The first mode we call the search mode, where we're just trying to learn about the network as much as possible. The second mode we call the list mode, where we think we've got everyone in the network, we've recovered the underlying sampling frame, and then we recruit randomly from that to be able to kind of come up with an inference. So the idea is we push the sample in the search mode to uncover new parts of the network, and then in the list mode, we try and sample to get as close to a uniform random sample from the network as it's unfolded. So we know what the network, we know all the members of the network, and so we know how to pull people at random from that to come up with a kind of representative estimate. So the idea would be, as you sample through the network and you sample more and more people, the number of nominated individuals eventually converges, so this is the green line, converges to an estimate of the network size. So we use a kind of network size estimation procedure to come up with, we think this network has 1,092 nodes, and as the sample unfolds in the network, we start seeing that these two have kind of converged as a process, and that it looks like we've enumerated the entire sampling frame, so now we can feel confident that we're able to kind of have an effectively simple random sample from that list. So we tested this in a number of ways. This is testing it in a particularly thorny situation for RDS, a relatively kind of sparse bottleneck structured network from AdHealth. There's a lot of homophily in the data. There's certainly this kind of bottleneck situation, but it's not like there's only one bridge between those 2 places. So we tested the simulated network sampling with memory on this and thought about how it performed compared to respondent-driven sampling. So this is sort of the original proposal, and then we tested it with different ways of thinking about numbers of alters that you collect information on, numbers of referrals that are made, how much researcher control really is the case. And what you see is all 3 of the different NSM ways, in general, converge to the population probability as the sample goes on, whereas RDS, the variability stays super high. That design effect remains really high, whereas samples of different sizes basically converge to the correct results. And in general, we've found that this NSM procedure resulted in no increases in biases across repeated kind of simulation sampling, but that it reduced the design effects by 98.5% across the 225 networks that we tested it in. So effectively, reducing design effects 98.5% means bringing it back to the statistical properties from a sampling variance perspective of simple random sampling, which is really advantageous to be able to kind of make strong inferences. Now, that's all great in theory. You can do all sorts of cool stuff on the computer. Does it actually work in practice? Can you actually survey populations in the real world? And so this is where I took off and worked at Penn State, and Giovanna and Ted kept working on empirical kind of components of NSM, and they fielded relatively recently a sample of Chinese immigrants in the Raleigh-Durham area, where they used NSM protocols to survey the respondents. And the advantage of this is because Chinese immigrants are well enumerated in the American Community Survey, we can compare kind of the attributes from a real-world sample to the attributes of the population kind of as gold, like a gold standard kind of attribute. And what they found is that they were able to recruit 482 people through doing this, learned about an additional 1,100 or so people, and that the sample was effective. One thing that was particularly kind of compelling, these are the results for kind of the population averages versus the empirical results. And you can see the deviation from the NSM sample and the ACS tends to be very, very low, with the exception of the citizen attribute, where the NSM results didn't perform as well as we would have hoped, I think. But with most other attributes, it performed pretty well for sampling this population. And one thing that's really nice with NSM vis-a-vis RDS is we can actually calculate response rates by traditional metrics. Because the researcher has more control, the researcher says, we'd like you to recruit this person, or we'll contact them for you, we can actually calculate what % of refusals and things like that. So the NSM response rates, 72.5% in person, which compares to the PSID immigrant recontact rates. So these are people that participate in the survey, and then they were able to find them again, and whether they consented to participate the second time. So these are people that are primed to participate anyway. Their response rate is about 68%. So this is a very advantageous response rate for far cheaper than is traditionally the case for surveys of immigrants. If you look at the cost effectiveness of the interviews, they also randomized mode to test whether web-based or phone-based or in-person worked. And you can see some discrepancies between these. You get higher response rates with in-person sampling, but it costs a lot more. And there's some trade-offs there that are worth paying attention to, but I'll elide those for now. And it costs far less per case, successfully recruited case, to do NSM than it does for large surveys like Health and Retirement Survey or PSID or something like that. And this includes, not just incentives to respondents, but all the costs associated with running the sample. And so the other thing that I would highlight with NSM is that it tells us about individuals who are in the sample, and this pertains to some of the ethical issues that we discussed, tells us about individuals who are in the population and the network structure of the population beyond just the recruited people who participate. And so we can learn about the broader network structure of the population and interesting things about homophily in that network, or communities in that network, or how that overlaps with various attributes. So this is a pilot study we had done in Tanzania in 2014, I think, where we sampled Chinese migrants to Dar es Salaam, and we used NSM to sample people. So these are the sampled individuals as well as those they reported on. And you can see really strong clustering in the network based on the attributes, based on the province of origin that each person comes from. And what's nice about this is this wouldn't have been obvious from just the respondent-driven component or just the people who participated in the survey. We really needed to be able to see the nominated but unsampled people and the reports of the respondents about those people to really discern this level of clustering. So in conclusion, I think there's a lot of possibilities with network-based sampling that are still kind of untapped. There's this RDS approach, which I think is effective, yields cost-effective, quick samples, but has this design effect problem and to some extent a bias problem. There's also opportunities like NSM to learn about samples that are harder to collect or give you lower design effects. But the problem with the NSM-based approach is that it is costly and difficult to implement, not as bad as traditional surveys, but but still some challenges. So there's a lot more that could be done, but I think to give a plug to Jimmy's work, I think that more of this kind of literature could benefit from reading about kind of the standard social network data collection protocols and the opportunities inherent in that to learn about network structure beyond just the people who are sampled, and to use that to inform the network sampling approaches, both in diagnostic sense, new estimators, and new research design components like NSM. And I think that there's been a lot of attention in the RDS literature to these statistical fixes, but not enough on the design fixes. So I hope this gave you some ideas to think about kind of design-based ways to change the sampling protocols to yield more effective and more accurate samples. So thank you.
Awesome. Critically on time. All right, questions or comments?
Yeah.
Do you think there's a sweet spot in terms of the incentive that's offered? $15, $20 would
It's going to depend so much on the population that I don't think it would be responsible to give you like a specific number. I mean, if you're recruiting in Uganda versus if you're recruiting in Singapore, you're going to have very different kind of local economies and things like that that need to be taken into account. But certainly, as I mentioned earlier, I really do think that there is the potential for coercion, and you need to be cognizant of that, particularly with populations at high risk, like people who inject drugs and things like that. There's some qualitative work suggesting that like RDS coupons enter the economy, essentially, of some of these communities and could result in kind of people getting mugged and things like that. So it's really worth thinking about ethical considerations, and that's going to vary so much from population to population that a single number is not a fair thing to give.
So one of the things that I was curious about when I saw this, the simulations you did is you're comparing the design effects for simple random sampling of RDS. What happens if the trait you're trying to feature is really clustered in that? In which case I would assume that simple random sample would be pretty bad, and RDS should be good.
Well, no, in a simple random sample, it wouldn't matter if it's clustered or not, right? Because you're just sampling, like you have a list of everyone, you're just picking them at random.
Right, but you might only get 3 of them. Whereas
Well, that would be a very rare trait.
right, so imagine a rare hidden root trait, which is the kind of thing we typically go after. So if I want to get IDU in Durham, the vast majority of people I sample random sample are not going to be IDU. Right?
So but that's true for our RDS too. Like if, in that circumstance, if you were to sample the population of Durham at random or with RDS, it's probably not going to hit the IDU individuals. So it's really kind of boundary specification on the population.
So in that case, the recovery rate of the rare event is worth the non-independence that's coming out of the RDS.
Yeah, I also think, rare events are really, all sample methods struggle tremendously with very rare attributes, right? Just because if, say there's 9 people in a community of 10,000 or something, if you get one person who misreports or fills in the bubble wrong or whatever it is, then your estimates are totally bunked. So measurement error enters heavily into that problem too.
Thanks. This is another extensive question. So when you're thinking about looking at different populations and you have the incentives, how do you run into issues or how do you talk about bias in terms of, maybe some of the drug users who are like not so bad off are not going to be really excited about using coupon, whereas other folks who may be in more dire circumstances are like, yes, this is great.
Yeah, so I think Nina actually has a paper where they collected data and they did the kind of try to estimate attributes of the network members, and then they used that in their kind of adjustments. And so they made degree-based adjustments that took into account the kind of selective recruitment probabilities and not just the degree, and it yielded better estimates and simulation-based results. And so that's where I think collecting that kind of information is pretty vital for you to be able to come up with statistical estimators that account for that kind of phenomenon. And so, and the traditional RDS diagnostic stuff that's been out for a few years also recommends collecting reasons that people recruited others into the survey and things like that, which would allow you to be able to make that kind of adjustment, or at least to say, like, we recognize that this is a potential problem. I think just a completely blindfolded sample through the population is a real challenge for RDS. Maybe it looks great, but you don't recognize the problems that exist, which really impede the ability to evaluate whether it's giving you results that are worthwhile at all. Thanks. Yep.
There are peer influences, so have you ever faced problems some kids feel I'm not engaged in my group because I didn't get reports?
So personally, our IOB will not let us do any adolescent recruitment. They're pretty stringent about this. I think you really need to, they make you go through a lot of steps to be able to do adolescent recruitment. So I have not done adolescent recruitment. I know John Schneider at UChicago has done a number of RDS studies of young black men who have sex with men in Chicago, which is one of the groups that is seeing skyrocketing rates of HIV and things like that, really high risk population. In those samples, I believe he samples 16-plus-year-olds, but I'm not sure what specific rules he's done to get around parental consent issues, which I imagine are probably not feasible to obtain. So I don't know specifically, but John Schneider at UChicago would be looking at his publications would be where I would look to find that information. In terms of the peer kind of recruitment thing and in-group, out-group components, I think that's a worry with RDS, and where I think kind of ethnographic work in RDS samples actually has a greater potential to tell us more things. As I mentioned, the work on entering the coupons entering the economy of places, that was found by ethnographic research kind of conducted in parallel to RDS. And I think that more of that effort would be worthwhile to better understand how it might change the community or act as itself as a network intervention of sorts.
I was thinking that whether, how do you think about the contextual culture or the ethnic culture of the human population will affect the referral trend process?
Right, so the first question is about sort of the structure of the data. And I'm happy to talk about that offline, but I think I'm out of time and we need to go to the next one. Oh, okay, just repeat the question. I thought I was getting the hook and I had to go, which is not uncommon for me. So the analytic structure of the data. How are RDS data typically organized? Typically, you have the pair level recruitment data. So you give a coupon to person 1, they give it to person 2, and you have some way that you can link them, and that is typically entered into the RDS. There's an RDS-R package which keeps track of that. There's an RDS data format that handles that. In some more advanced estimators, they also take into account the timing of recruitment, so that'll be a component of that edge is when that recruitment actually occurred. And so you can instead of estimating it as a degree-based thing, estimating it as a time-based kind of process unfolding in the network. So those are the two kind of structures. But yeah, with RDS data, you would have an existing data set, and you could put it into the RDS package, and it structures it as an RDS network. as a kind of subset, just like StatNet treats networks as networks and things like that. So it's got a kind of native R database format. You could analyze it with other software as well. I believe in Stata it treats it as like an XT set kind of product. So there's different formats for different data sets. There's also a standalone RDS package called RDS SAT that usually is used to kind of manage coupons as well, and that kind of computes the results for you kind of directly through kind of same procedure. The key thing is knowing who recruited whom and degree. The second question was about culture of province and whether different provinces have different kind of recruitment levels in the population. We certainly saw that, but what we found is that that wasn't above and beyond what would be expected from kind of the population size kind of stuff is my recollection. Although it was a couple years ago, so.
Thank you, Ashton. I appreciate it.